Good morning, everybody. With you, Mr. Samir Awad. We're going today to get chemistry session for grade 9, chapter 2, lesson 1, which is properties of matter. If we get to the properties of matter, we will start by why do all samples of the substance have the same intensive properties? If you want to compare between substance, you would go to the color, you would go to the texture, you would go if it's shiny or not. That you can see, sometimes it's all intensive. So let's go inside more. What you observed when you look at a particular sample of matter is its properties. Is it solid, shiny, or dull? Does the liquid flow quickly or slowly? Yeah, like in water and oil or water and honey. Is gas odorless or does it have a smell? That's another one. You can see some gases like oxygen odorless, ammonia, have a vulgar, smell. Properties used to describe matter can classify it as extensive or intensive. If it depends on the mass and volume, the amount of matter exactly, we can say it's extensive. If it doesn't depend on mass and volume, we can say it's intensive. Let's get more extensive properties. Like it depends on amount of matter or the space the matter is taking. Let's see, we have the basketball here. The mass of it is more than of the golf ball. So that's the difference depend on which matter will get more amount. And on the other side, the volume of the basketball is more than the volume of the golf ball. So that's depend on the volume too. So it's extensive. So extensive property is the property that depends on the amount of matter in a sample. Let's go to another one, intensive properties. Intensive properties, let's see, what is the matter or the composition of the matter here for, the basketball? It might be leather, rubber, or a synthetic composite. That's or intensive, not depending on the mass or the volume of it. For example, leather balls are suitable for indoor play, but not outdoor play. For example, if we set intensive for the lesser ball, it can absorb more of water and dirt if it's getting out for playing. But inside, indoor, it's better. The rubber one for outside is better too. It depends on the absorbency, and the absorbency will be, exactly intensive property. So the intensive property is the property that depends on the type of the matter in the sample, not the amount of the matter. Identifying a substance. What if we want to identify the substance? Look at these two substances. You will get aluminum can and a copper watering, can or watering can mainly of copper. That's different according to the material of them. So the matter that has a uniform and definite composition is called substance. Whatever it was element like aluminum or copper, or whatever it was a compound like water, it's a definite, specific, unique structure for it only. Every sample of a given substance has identical intensive properties because every sample has the same composition. So if I get a sample from the same matter, we'll get the same intensive properties from the matter. So aluminum and copper have some properties in common, but there are differences beside their distinctive colors. Aluminum is highly reflective. It's often used in silver paint. Pure copper coal can scratch the surface of aluminum because copper is harder than aluminum. Copper is a conductor of heat and electricity. So that's a good one too for copper. And copper and aluminum are both malleable and you know they can be hammered and get into sheets without breaking. Let's go further. For hardness, color, conductivity, and malleability are examples for physical properties. And a physical property is a quality or a condition of substance that can observe it or can be observed or measured without changing the substance composition. So it will still as it is. The copper, you can see it as a can, you can see it as a sheet, but it is still copper. Nothing at all happened for it. The water can be ice, can be steam, but there's nothing happen for its composition. It is still H2O. That's some examples for physical properties for the substance, like a state of matter, gas, liquid, and solid color, colorless, or getting another color, yeah, or melting point and boiling point. They are different according to the substance itself and its specific unique structure for each substance. Let's go further. Identifying a substance too, we can get the physical properties, for example, for the water, 100 Celsius for boiling and 0 Celsius for melting point. That's specific for water only. And for the colorless substance also, which is ethanol, the boiling point is 78 Celsius, and on the other side, the melting point is negative 117 Celsius. So that's specific for each matter. Yeah. What are three states of matter, guys? We have three states of matter, as we said before in the states. Yeah, exactly. It's a solid, liquid, and gas. Let's move over, guys. Solid is a form of matter that has a definite shape and volume. You will see here the particles of the matter here are gathering together, and the intermolecular spaces between them are very little or can be negligible. Let's move further for the solid. The solid is almost incompressible, guys. You cannot compress it. Liquid, the particles in liquid are close in contact, but they are movable, not like solid. You can see that the water or even any liquid, when you move it, it can move its particles in all directions. That's all about the attraction force between the molecules and the intermolecular space. As you see, it's more than of the solid, so it can be flexible more than solid. Yeah, and the volume of liquid is fixed and constant, but for its shape, it's taking the shape of the container it's inside. Let's move further, guys, for gases. And gases, like a liquid in its shape, it's getting the shape of the container, but it's getting also the volume of the container because it can expand, not like of the liquid and salt. On the other side, yeah, gas, for all of this space between the particles far away and apart of each other, so it can be compressible to smaller volume, and that's good for the gases too. Yeah, we have two definitions for the gas state. One of them is gas, and the other is, and the other is vapor. If we get to gas, yeah, if the substance originally is a gas, like in room temperature for the oxygen, it will be gaseous state for it. But on the other side, if the substance is not originally in its room temperature gas, it was a liquid or a solid, for example, like water. So in its gaseous state, it will be called as vapor. Yeah. How can physical changes classify? Yeah, if we have change in physical changes, like it will be reversible or irreversible. For example, melting something like gallium, yeah, it depends on 30 Celsius, temperature. So 30 Celsius degrees is enough to melt it. So if you hand it in your hand, only your body temperature can melt it. So melting or evaporating or something like that, you can melt something and get back to solidify it by freezing, or you can evaporate something and you can get condensated into liquid again. That physical change, guys, or properties, we can call it, reversible. But on the other side, if you break something, split something, grind a car, for example, cutting hair, breaking or crashing an egg, that's physical change that is irreversible, cannot get back to its state. There is difference between, guys, two sets of words. Each set describes a different type of physical change. Physical changes can be classified as reversible or irreversible. For example, melting is an example of reversible physical change. If a sample of gallium cools below its melting point, so the liquid will be solid again. All physical changes, guys, that involve a change from one state to another are reversible. But for example, cutting hair, filling nails, and cracking an egg are examples of irreversible changes. Let's consolidate more by the end. Yeah, never forget about every sample of a given substance has identical intensive properties because every sample has the same composition. And for example, never forget about three states of matter. Yeah, solid, liquid, and gas. Yeah, and we can get from state to another by physical change, exactly. And the physical change can be classified as reversible and irreversible. Thank you guys for your time. We're with you, Mr. Samir Awad, and you are to work through Pearson to get your homeworks, guys, and also to start to give it to me again through uploading in Pearson Realize. Thank you guys for your time. Bye-bye.